The objective of our project is to levitate a 3D printed Star Wars X-Wing fighter connected to a magnet using a solenoid-driven feedback control system. After a cost analysis, we decided to buy an already existing solenoid rather than creating one ourselves. The solenoid needed to be hooked up to a DC power supply in order to generate a magnetic field. It is rated between 5 and 12 volts. When connected, it can support roughly 8 pounds of weight. This is an example of our solenoid in action. We used an Arduino Uno R3 controller to code the system. We will also utilize push buttons to increase or decrease the tolerance of the levitating object, a TIP 120 transistor to interface our voltage and current with our Arduino, and a 1N4007 diode to allow the current to only flow in one direction, similar to how check valve blocks work. We will utilize a breadboard, wooden stand, wires, and a 3D printed support to assemble everything. We hooked up our Hall effect sensor to the DC power supply. We were able to view how the distance of the magnet from the sensor affected the sensor output. We developed this plot, which shows an inverse square relationship as we moved closer to the sensor from 5 millimeters out. This plot was fitted with a linear line, which we acknowledge is incorrect, but our data and methodology was deemed appropriate by our professor. To create our circuit, we collected a breadboard, several wires, the Arduino, the push-button switches, the diode, and the resistor. We plugged the resistor into the 5-port on the Arduino and connected it to the B terminal of the transistor. The E terminal of the transistor was connected in parallel to the ground with the negative terminal on the DC power supply and the micro switches. The diode was connected to the positive and negative terminals of the solenoid. The former was connected to the positive terminal of the power supply. The purpose of the push-button switches is to raise and lower the position of the magnet. In theory, that is their function, but ours did not work. The other side of the terminal is connected to the 5-volt, and the ground terminals of the Arduino. Also, they are connected to the DC power supply. As you can see, we were able to get a response from our magnetic levitator. Our object did not levitate, but it could be stabilized and lifted slightly out of our hands. The on-off function did not respond quickly enough to actually levitate our object for any period of time. We learned that if we had had a stronger magnet or more space for levitation to occur, we would most likely be able to get the desired response from our levitator. Also, with a stronger magnet, we could lower the Hall effect sensor and increase the distance from the electromagnet.